content until Web 2. So in Web 2, people kind of discovered that you could actually create economies by allowing people to post and create content. So major companies invested, like your Amazon Web Services, or your Google, or your other, etc., etc. So they invested into infrastructure, and it led to centralized control over your user data. So your data is now controlled by companies because, well, they invested in it. They invested in the infrastructure to host it. They invested in the marketing to get you on their platform, and hence you have this predicament that we have. But there is a technology that is going to cause a steady continuum, which is a steady change, and that technology is blockchain. But we have to ask ourselves, what is a blockchain? Does anybody actually know what a blockchain is? Could anybody? What's a blockchain? Anybody?
Decentralized ledger.
It's a decentralized ledger, yeah. But what's a decentralized ledger?
Centralized database.
It's a centralized it's not quite a centralized database. Nobody? Nobody can tell me?
It's a layer 1 ledger.
It is a record of transaction, but how is it generated? There's a key component of a blockchain. Not quite that technical. It's really just a system, a way of recording information that makes it immutable. And immutable means it's non-changing. And you might ask yourself, like, why is that important? Well, it's incredibly important because of security. Now, the blockchain itself does not ensure data correctness, because I think that's a lot of misconceptions about blockchain. So it does record data in an immutable manner, but it does not ensure correctness. Your wallet, for example, could be compromised by a hacker, whatever it may be. We don't really experience hackers in internet computer, but on other blockchains that can happen. And that hacker can actually infiltrate your system and transfer your tokens or whatever it may be. That's an actual incorrect, well, not incorrect, but it's a malicious transaction. So the blockchain will actually record it as being legitimate, but it's like a malicious transaction. So that's a vulnerability of blockchain. But really, the point is, it's a secure system that records information in a way that cannot be altered. I hope I didn't lose you guys right there. Did I?
No.
No? Okay, let's go. So now we have the world computer, and it really is a network of subnet blockchains that come together to create an autonomous cloud. That's a mouthful. Why is it autonomous? Does anybody know why the internet computer is autonomous?
It's decentralized.
Because it's decentralized. It is decentralized, but what's the main component of ICP, why it's autonomous? You go on it every day. If you hold ICP, you go on it every day. Nobody?
NNS.
Exactly. It's DAO governed. Go ahead. So the internet computer functions in 4 layers. The architecture is in 4 layers. Peer-to-peer. There are probably, I say, 20, 30 people in here. We have to talk to each other, right? We have to talk to each other. If we have a problem or receive a message, we have to speak to each other, right? And we have to agree. What's that? Consensus. And then messaging. The actual message or data is passed to the network. And then execution. The actual changes is executed to the code. Does that make sense? Mm-hmm. All right. So that 4-layer structure that I just explained is used in each node, and the nodes make up the subnet. So you have nodes in the subnet that create subnet blockchains. So that's a unique feature of ICP in that it's not just one entire subnet, it's different subnet blockchains coming together to work together to build the entire protocol. Well, it's really just a lot of threshold cryptography and kind of like a lot of technical stuff, but at the core of it, it's independent nodes working together in a subnet, and that subnet working together with the other subnet that exists across different geographical locations, jurisdictions, and they all come together to make ICP. So the internet computer is so powerful it can play the role of Web 3. It can play the role of Cloud 3.0 in that you can build exclusively from canister software. And canister software is a new generation of smart contracts. And smart contracts, anybody know what a smart contract is? Like originally, like when smart contracts were introduced, what were they? What were they intended to be? No?
Tokens?
No, not quite. So, well, a smart contract in the traditional sense is a self-executing contract. That means if it's written correctly and coded correctly, it will execute the same way every single time you run it. That's what a smart contract is. But a canister smart contract is a little bit different. A canister smart contract is tamper-proof because I just explained, it is replicated all across multiple different subnets. So it's secure, it's unstoppable, because when you deploy a canister to ICP, you actually deploy it to a subnet. And that subnet has the different nodes that I just explained. And the different nodes all run the same application. So when you deploy, it's deployed on all the nodes in the subnet. Which means even if one single node or multiple nodes in that subnet goes down, your application is still running. It's composable. It's both state and logic. That's what composable it means. Autonomous, as we just discussed with the NNS. Tokenizable, meaning you can create tokens, you can make it fungible, non-fungible. Multi-chain, ICP can communicate across different blockchains. It's scalable because it's in the subnet, and the subnet technically has infinite scalability because you can have as many nodes as you want. Efficient. ICP does a lot more computation compared to other chains, and HTTP outcomes, which is actually, I think, one of the biggest breakthroughs, because previously smart contracts were limited to data that existed within the networks of the blockchain that they existed on. But canisters can actually call outside of their network to get information, which is really important. So canisters are a bundle of WASM logic and data. Really, you have the logic, which is, let's say you have a function, 1 plus 1. You have a variable within that function. That's the data. And when you run that function, it updates the data. So when you go to execute that logic, it goes through the consensus mechanism. Well, it goes from peer-to-peer to consensus, to messaging, to execution. And another really important feature is orthogonal persistence, which means the data persists even after. You know, like when you have, did you learn about RAM and ROM, right? Everybody learned about RAM and ROM, right? So like when you turn off your computer, you don't expect all your data to be gone, right? It's similar where when you upgrade your application, you don't expect all your data or your user data to be gone. And orthogonal persistence enables this, and it actually eliminates one of the biggest problems that web developers have, is because in traditional IT stacks, you have to have your database external from your logic. Your logic is what you use to operate on your database traditionally. But now you have those combined in one, so you have everything in one place. Go ahead. Yeah, but again, why does this matter? Centralization is great, right? I mean, Amazon Web Services, Microsoft Azure, Firebase, they're all great products. I mean, the three companies combined spent, I think, like 24 billion on infrastructure. It's great. I mean, probably most of the platforms that we use these systems. So it's great, right? Until something goes wrong. Until there's a code strike, until your account gets banned. It's all great until something goes wrong. So you trust these platforms with your data until there's a hack, or until there's censorship or some major event occurs. And the importance of your data ownership isn't clear until you actually need it. So until your business is basically wiped off the map just because you're maybe not dislike, but you get the point. If you are trusting these big corporations with your data, I don't think you should, because you can't rely on them to have your best interests at heart. So what's the solution? The solution really is building on ICP, building it on autonomous software where you really have control over your data, where you really can guide and push your software in the direction that you'd like to. And yeah, I think that was the end, right? Yeah, so if you would like to connect with me, you can do so on X. Also, big shout out to Javier from Quantum Leap Labs. He's one of the major reasons why this even happened. So I'd like to thank him for giving me the opportunity to come here and present to you. And yeah, anybody have any questions? I feel like we should have more of a discussion considering we're all here. If you have any questions, we can have a Q&A, and maybe I can answer any questions you have about the protocol.
Where are we at with large language models, internally, externally, leveraging them? What have you seen?
So for the language that I use, which is Motoko, I'm not sure we have running LLMs. I know that there are other languages like Rust that can run LLMs, but I haven't seen that in Motoko yet. Maybe they're working on something, but I haven't seen that. Yeah.
So is there a Rust, is there any production on a Rust built software that leverages an LLM on the ICP?
Yeah, so basically from how I understand it, because there have been some examples, what they've done is basically taken off-chain LLMs, run them on-chain, whether it be Llama or whichever model there is, they just take them in a specific language like Rust and run them on-chain. Any other questions?
What makes ICP different compared to like Near, like another AI chain?
Well, the biggest difference between ICP and any other blockchain is they actually do it on-chain. Like, there's nodes. As I explained, there's an entire subnet. When you deploy your application, it's not going to one or two. It's going to an entire
Blockchain.
Yeah, it's going to an entire subnet. So, as I said, the characteristics or the strengths is that it's composable, it's tokenizable, it's tamper-proof. It's all these things that is not really, it's not there on other blockchains, because what they've really done is done a ground-up solution, full stack, on-chain. It's intended to be an alternative to the traditional IT tech stack. So that's the real power of ICP, real power over your data, full control over your application. That's the real power of ICP.
So as a Motoko developer, do you see the pipeline that's coming through some of your work? Is there going to be more projects coming into the NNS? Because right now it's, a few here and there, but not a lot, or not enough in my opinion. So as a developer, do you see the demand?
Yeah, I think I do. I think the problem with some people might not feel like the best about, I think what you're referring to is the SNS. Mm-hmm. There's been, I was one of the first contributors in like Sonic. I was there when there was SNS1. I don't think people have had the best experience with the SNS, so that might be why there's not as much enthusiasm about these or about going that pathway. But I think there's a huge market for ICP and the technology in general, whether it be in DeFi or trying to migrate actual existing applications from Web 2 to Web 3. I think that might be the best solution from a business standpoint, targeting actual running businesses and trying to migrate them over. I think that might be the best use case in this context as like a developer. I also think a lot of the applications that are existing has to be redesigned to fit within the ICP framework. So there's a lot of work to be done in that aspect as well. Any more?
Are there opportunities for someone with minimal experience in ICP to get involved and generate a living, like income, by getting involved? And what would be the opportunity?
Could you repeat the question? You're asking if someone has minimal experience in coding, for example, if they can actually come to ICP and develop a product?
Maybe broad experience.
Well, it does require coding experience to develop on Internet Computer, as it would to develop on Amazon Web Services. Or if you're asking if the documentation and support is there, from my experience, I would say yes, because so I've been in Motoko for maybe a year and a half. I started off like writing articles, just me actually sitting around coding in Motoko. And the Definity Foundation reached out to me and kind of encouraged me to like pursue like a grant, or whether it be just giving me support in general. They did give me multiple grants, but the support is there from my experience. Perhaps another person might say there isn't, but in my experience there has been, because they basically reached out to me and gave me the support that I needed at that time. And also, I think it's just hunger. Like, you have to want it. I mean, it's not easy to develop.